I am Dr. Kakoli Banerjee, Associate Professor from JSS Academy of Technical Education. Today, I will be talking about multiprogramming with fixed partition and multiprogramming with variable partitioning in operating system course. So, basically when we talk about memory and memory allocation, we all know that when we talk about the operating system concept, in case of the operating system, it is one of the main jobs of the operating system to allocate memory to the processes that are there, the processes which request for memory. And we know when we talk about multiprogramming, in the CPU we are having multiple processes or residing inside the system which are getting executed parallelly, and that is why we have a concept known as multiprogramming. So, let us start. When we talk about memory allocation can be in two ways. We have the contiguous memory allocation and we have the non-contiguous memory allocation. Under the contiguous memory allocation, we have this fixed partitioning and we have the variable partitioning techniques. So, right now in this particular lecture, we will be talking about these two techniques. In these two techniques, when we start with the fixed partitioning that was initially used, one major disadvantage that we have in fixed partitioning is that it restricts the number of or restricts the degree of multiprogramming. So, basically you can consider that the fixed partition is something like this is your memory space and we have divided it into 5 fixed partitions. So, let us say this was 100 kb, this was also 100 kb, 50 kb, 50 kb and so on. So, what will happen when we have fixed our memory into these 5 partitions? That means only 5 processes can reside in the memory at that time. If a 6th process comes in, it has to wait for any one of these processes to finish and release the memory. So, this is one problem that we have with fixed partitioning. Apart from that, in fixed partitioning, the partition sizes are predefined. That means, if there is a process, let us say all this memory is already full, this part is already full. So, what will happen? Let us say a 10 kb process has entered. Now, this 10 kb process will go into this 100 kb fixed partition. So, this remaining 90 kb space will go waste. So, these are the problems that we have in fixed partitioning. So, let us go through it once. It says that the memory is divided into fixed number of partitions of different sizes which may suit the range of usability occurring as per the program size. So, maybe like the programs that are coming or the processes that are coming in the memory, it is between size 50 and 100 kb. So, if we keep the size 100 kb, that is good enough. All the processes can be can enter the memory, right. So, it depends upon the type of processes that are coming inside the memory, and depending on that we fix the size of the partition. Each partition can accommodate exactly one process. Thus, the degree of multiprogramming is fixed. Now, this is the main problem that I was talking about. In each partition we can have only one process, and because of this one process, the degree of multiprogramming is restricted. So, over here like we saw that 90 kb space was left out, which could have been used by some other process. But what is happening, because it is a restriction that only one page or only one process can stay in one partition. So, this is restricting the number of processes that can enter the main memory at the same time, right. Next, it says whenever a program needs to be loaded, a partition big enough to accommodate the program is allocated. So, whenever a process is trying to come inside, so a partition which can actually let us say satisfy the requirements of the memory requirements of that process, it is allocated to that particular program or the process, right. Next it says, since a program may not exactly fit the allocated portion, some space may be left unoccupied after loading the program. This space is wasted and is termed as internal fragmentation. Now, basically this 90 kb space which has been wasted and which is not going to be used by any other process is called internal fragmentation. So, this is basically the definition also of internal fragmentation. So, it is what? It is the space that is wasted after allocation of a particular process in the partition. Whatever space is left out, because it cannot be occupied by any other process. So, that space goes wasted, and that is termed as internal fragmentation. Now, let us see how fixed partitioning works. So, over here I have taken an example. You can see these are the partition IDs. We have taken 5 partitions. These are the partition size. The first 3 partitions are of 50 kb size, the fourth one is 100 kb and the last one is 250 kb, and these are the partition base. Partition base is nothing but it is the starting of the partition. So, you can visualize the memory allocation space, physical memory allocation space. So, this was your 50 kb size. So, it has been allocated to a 45 kb process. So, this 5 kb has gone as internal fragmentation. Next, we have this again 50 k size. This is free for further allocation. So, over here you can see that it is free. It is showing in the partition status as free. Coming to next, this was again a 50 k size partition. The process that has entered into it is of 40 k size and 10 k has gone as internal fragmentation, right. So, this is also done. The next one that we have is of 100 kb size, and after 100 kb size the process that has entered into is of 80 kb. So, again this 20 kb has gone as internal fragmentation. The last one 250 kb is still free and it is there in the table also, right. Now, what are the advantages? The advantages of fixed partitioning is very simple. It says that the implementation is very simple. Obviously, you can see it is a straightforward implementation. Wherever a process is coming, the a particular partition which can satisfy its requirement, that partition is allocated to that process. Next, the process overheads are low. We are not going for multiple search and overhead search. So, the overheads are not there in the fixed partitioning technique. Next, what are the disadvantages? Disadvantages we have already discussed in the previous slide, but to repeat it again, the degree of multi-program is fixed. This is one very big disadvantage with the fixed partitioning technique. The degree of multi-program is fixed since the number of partitions are fixed, and it suffers from the problem of internal fragmentation, because in one particular block, in one particular memory block, only one process can reside at a time. So, the remaining part of that block goes waste as internal fragmentation. Let us see the variable partitioning technique. In terms of multi-programming, this technique is much better, because it does not restrict the number of processes that can reside in the memory at any given moment. So, what happens? It says initially the entire available memory is treated as a single partition. So, if we are having a 500 kb block, so this is one memory block. The entire part is taken as one single partition. Next, the incoming programs requesting memory allocation are queued up. So, whichever programs are coming in which are requesting for any internal memory, so they are put in a queue, right. So, they are queued up. A waiting program is loaded only when a free partition big enough to fit the program is available. So, a program will come into the memory only when it has a big enough partition which can fit that program into itself, right. So, it has to be big enough to fit the program. When a program is loaded, it is allocated a space exactly equal to its size. The balance unoccupied space in the allocated partition is treated as another free partition. So, whatever the process is coming, whichever process is coming, whatever size it is having, exactly same size of a partition is created. Let us say there is a process A which is coming with a requirement of 100 KB size. So, what will happen? A block will be immediately created from 0 to 100 and A will be allocated to that particular memory block. Now, this remaining 400, what will happen? This is a new partition available for upcoming programs, right. If let us say there is another process B with requirement of 50 KB, another block will be created till 150 KB and B will be allocated to it, and the remaining 350 will be used as a new block, right. Whenever a process terminates, it releases the partition occupied. So, obviously, if this B finishes or terminates, it is going to release the partition. If the released partition is contiguous to another free partition, now it is very important. If this partition is contiguous to another free partition, that means this partition was contiguous to this particular partition which was free. So, what happens? They are clubbed together to make one big partition again, right. So, that is what it is saying over here. It says that when the released partition is contiguous to another free partition, then both the free partition are clubbed together into one free partition. So, if this B is gone, now this will go back and this will be back a block of 400 KB. We will again have a block of 400 KB available with us, right. But these partitions have to be contiguous in nature, right. Next, it says when a free partition is too small to accommodate any process or program, it is called external fragmentation. Now, we have already talked about internal fragmentation. We need to understand what is external fragmentation, and external fragmentation usually takes place when we are having variable partitioning. So, in case of variable partitioning, what happens? Let us say we had this block and these blocks have been created like this. So, let us say this one is blocked, this one is blocked, this one is blocked. That means these portions have been allocated to some processes that have entered the memory. Now, let us say this free block is of size 50 KB and a process that is trying to enter the memory is of size 100 KB. So, although we had space left with us, but this 100 KB process cannot enter into this 50 KB block. So, this 50 KB now becomes external fragmentation. That means, we are having memory space left, but it is not big enough to satisfy the requirement of any process. So, it acts as external fragmentation. So, this is also the definition of your external fragmentation. And if there exists more than one fragments lost due to external fragmentation, these fragments can be joined together using compaction. Now, compaction is a technique where we can join multiple free spaces that are left here and there. So, there can be very small processes which have come inside and they have taken some space and they have finished their execution and they have left. So, these free memory blocks are left out here and there. So, compaction is basically the process of clubbing all these free memories into one block, and the space that we retrieve or that we get after the process of compaction is big enough that it can take care of any other coming up program or process into the memory. So, this is compaction. Compaction is basically nothing else other than clubbing or bringing all the free space in one place. Okay. Now, this is how variable partitioning takes place. You can see these are the partition size that have been created on the requirement of the processes. You can see two of them are free also, partition size 20 and partition size 830. So, these are free, right. Why they are free? Maybe some process may have come in, like this one, a 20 KB process may have come inside and it has used this memory and it has finished its execution and left. So, now this partition has been created and it is of 20 KB size and it is very small for satisfying the requirement of any other process. So, that is why this is free. So, we are having external fragmentation as 20 over here and we are left with a big block of 830 KB size, which can be used by coming up processes, right. So, this is the variable partitioning. You can see we can have multiple processes in this block, right. So, it is not restricting the number of processes that can enter the memory depending on the memory size, right. We have already discussed about compaction and external fragmentation. So, just to repeat it again, external fragmentation, like over here you can see, is that memory portion that is being used by some process and later on after its completion it has left that memory space, and after leaving that memory space, this memory space is so small that it is not able to satisfy the requirement of any other process. In that case, it is going as a waste. So, that is your external fragmentation, and compaction is the process of bringing all these small spaces that have been left out in between and clubbing them into one memory block. So, this is what is external fragmentation and compaction. Now, talking about the different strategies for partition allocation. Again, this is a very important part of this variable and fixed partitioning technique. So, we have different strategies for allocating memory in both fixed partitioning and variable partitioning. So, we start with the first method or the first strategy, which is known as the first fit strategy. Very simple to implement, and this can be used in both fixed as well as in case of variable partitioning. As the name says, first fit means whenever there is a request, any process is coming with any memory request. So, the first available block is allocated to that process, right. We do not think about whether about external fragmentation or internal fragmentation, we just allocate the first available block to that particular process. So, this is first fit. What are the advantages? Advantages are that the search time is less. We are not searching depending on the size or any other category, we are just seeing that which is the first available block, and depending on the first available block we are making the allocation. What are the disadvantages? Disadvantages is that because of this technique, first fit technique, it suffers lot of fragmentation. It suffers from internal as well as external fragmentation. We will take an example and see how things change when we change these strategies, right. For the timing, this is one of the main disadvantages of first fit method. The next one, best fit. When we are talking about best fit, now what is the technique behind best fit? The technique behind best fit is that whichever best block is available, that means whichever smallest block of memory is available for that particular process, we are going to allocate that memory to that process. For example, let us say there is a process of 120 KB size and we are having two memory blocks, let us say 150 KB and 600 KB. So, what will happen? We will search for the smallest block that can satisfy the requirement of this process A. We could have allocated this 600 KB block also, it would have been very easy for us, but what the best fit says that it is going to search for the smallest memory block, and depending on the smallest memory block the allocation is done. Because we have allocated this particular memory block, the internal fragmentation is going to be very less, right. Again, the advantages is that the memory loss on account of fragmentation will be lesser than in case of first fit. So, when we compare it with the first fit technique, the memory loss in terms of fragmentation is going to be very less. What is the disadvantage? The disadvantage is that the search time will increase, because we are trying to search for the best block, right, which can satisfy its requirement. Coming to the last technique for memory partitioning, the last technique is known as worst fit. Now, the first fit technique and the best fit technique can be used for fixed partitioning as well as variable partitioning. But when we talk about this worst fit technique, it is good only for variable partitioning. If you are using it for fixed partitioning, the result can be catastrophic. So, never use worst fit for fixed partitioning. The concept behind worst fit is, it says that whenever a process comes, allocate it the biggest block. So, whichever biggest block is available in the memory at that given moment, allocate that block to any process that is entering. So, why to allocate the biggest block? Because we are going to have lot of internal fragmentation in that case. So, the reason it says that we are going to have internal fragmentation, but because we are talking about variable partitioning technique, that internal fragmentation can be used as a new block that can be used by any other process that is trying to enter the memory. So, if we are having a big enough block, let us say 600 KB, and there is a process of only 100 KB size. So, it says if this is the biggest block, allocate this block to the process A. So, 100 KB will be used, rest 500 KB is free for other processes to come in and use. So, but this technique cannot be used, we know that in case of fixed partitioning it is not possible. This can be done only in case of variable partitioning. So, the main advantage of worst fit is we get it when we are implementing variable partitioning technique. So, what are the advantages? It says it is expected to provide a smaller memory loss on account of fragmentation, because whatever memory is left out, it is being used for coming up processes. So, the memory loss in terms of fragmentation is very less. What are the disadvantages? Search time is larger than first fit obviously, but it is same as in case of best fit, and the algorithm is designed only for variable partitioning allocation, very important. By mistake, if it is used with fixed partitioning, the result will be suicidal. So, it is going to be used only with fixed partitioning technique. Now, let us quickly take an example and see how these strategies are used. I have taken a question, and over here you can see that these are the partitions available. We are having a 100 KB partition, a 500 KB partition, 200 KB partition and 300 KB partition. And what are the requests? The requests are A is coming, A is a process coming with 212 requirement, B with 417, C with 112 and D with 426, right. And this is a scenario where you have to find out the internal and the external fragmentation, right. So, let us say when we talk about the blocks, so this was the first 100 kb block, next we have the 500 kb block, followed by the 200 kb block, then 300 and the 600 kb block. So, this is what the partitions have been given to you in the question. So, starting with the first fit, you know first fit is just like whatever first available block you have that is satisfying your requirements, allocate it to that particular process. So, the first requirement was 212, this cannot be satisfied by the 100 kb block. So, what we have done, we have placed it in the 500 kb block. So, over here you can see the first internal fragmentation is 500 minus 212, right. Next what we are having 417. Now, 417 cannot go into any one of these because 500 block has been already used by process A. So, now it is a must that it has to go into this 600 kb block. So, it is going into this last block and over here the internal fragmentation is 600 minus 417. Coming up with the next one 112. So, 112 cannot be satisfied by 100 kb and because we are going by first in first fit. So, the first block that is available is of 200 kb and this 112 process is going into the 200 MB block. So, over here you can see this is there, right. Next what do we have? We have D process with requirement of 426 kb. Now, do we have memory left for 426 kb? Over here we are not left with any memory block which can satisfy this requirement. So, what are we left with? We are left with this 100 kb block and this 300 kb block. So, what is our internal fragmentation? Internal fragmentation we have already seen how we have calculated it and this is your internal fragmentation 549 kb and the external fragmentation is 400 MB because these two blocks are still free and we had a requirement of 426 kb, but it was not available for us. Similarly, if we go for best fit, you can see now we are searching for the processes, we are searching for the blocks where the process can get fitted at its best. So, A you can see because it was 212 kb size. So, it has taken this particular block, right, because it was of 300 size. B was 417. So, it has gone into the 500 kb block. C was 112. So, it has gone into the 200 kb block and D was 426. So, it has gone into the 600 kb block. So, this 100 kb is still free, right, but we are not going to have any external fragmentation because there is no pending process, right, all the processes have been satisfied. So, you can find the total internal fragmentation along with the external fragmentation which is not taking place over here. In the case of best fit, we are not having any external fragmentation. Similarly, in the worst fit, we just do the reverse, we search for the biggest block. So, the first process that is coming in 212, 600 was the biggest block, it has gone into the 600 block. The second process that was coming 417, next was the 500 kb block, it has gone into the 500 kb block. C 112, which was the next biggest block, the 300 kb block which has gone inside this. Now, this 100 kb and 200 kb is free, but it cannot be used for any allocation. So, over here you can see that the internal fragmentation has been calculated, and because there are pending processes and this memory, this 100 kb and 200 kb which are left here and here, right. So, this act as your external fragmentation. So, you can see over here this results tell you that which particular method is better. You will find when you will be using variable partitioning that the worst fit method is better. When we are using fixed partitioning, the best fit method will be better. So, depending upon the requirement, you can decide that which method is better for that given scenario. So, that is all. Thank you so much.